All right, I wanted to go over a couple problems from your homework just to make sure you're all on the same page. So let's go ahead and just do two problems from your homework about normal distribution. So this problem states steel rods are manufactured with a mean length of 29 centimeters. Because of variability in the manufacturing process, the lengths of the rods are approximately normally distributed with a standard deviation of 0.05 centimeters. What proportion of rods has a length less than 28.9 centimeters? All right, in order to do this, we just need to first check, is it normal? Yeah, it's normally distributed, which is great. That means we can do norm CDF. Now the mean is given as 29. The standard deviation is given as 0.05. So then what we're gonna do is get our calculator. I would normally draw a picture here, but it's hard for me to draw on the computer, but I would draw a normal curve, and we're going from 28.9 left because it says less than it. So I'm going to go on my calculator and do norm CDF. For the lower number, I just do a really negative number, and then it goes all the way up to 28.9. The mean is 29, and the standard deviation is 0.05. Put that in my calculator, and I get 0.0, it says round to 4 decimal places, so 0.0228. Yes. Great. So now, any rods that are shorter than 28.89 centimeters or longer than 29.11 centimeters are discarded. What proportion of rods will be discarded? Now, this is actually happening on both ends. If they're shorter, too short, or too long, then they're going to get rid of them. What I'm going to do here is I'm actually going to find the proportion between these two and then take the complement of it, do 1 minus that. So I'm going to, again, go to norm CDF. This time my lower bound is 28.89 and the upper bound is 29.11. The mean is still 29 and the standard deviation is 0.05. Now when I do that, I get 0.9721, or in other words, 97%. But that's the ones that we would keep. So I'm going to do the complement of that and do 1 minus that, and I get 0.0278. That would be the proportion that we're going to get rid of. Nice. So that means if we made 5,000 rods, how many are we going to get rid of? Well, that percent of them. So what I do is I just do 5,000 and I times it by that percentage. And it says round to the nearest integer. So I'm going to have 139 rods that I'm going to get rid of. Sweet. Okay, now we're going to change things up here a little bit. If an order comes in for 10,000 steel rods, how many rods should the plant manager expect to manufacture? The order states that all rods must be between 28.9 and 29.1. So slightly different numbers than what we saw before. So let's figure out what proportion of these rods are we keeping. So I'm going to do norm CDF again, just like what we did before. This time we're using 28.9 and 29.1. And what this is saying is that in the production process, I'm going to keep about 95% of them. Now this is a little tricky because it's not saying it's not asking us what 95% of 10,000 is. It's saying if we want 10,000 good rods, how many do we need to make? Now I would set this up as like an algebra equation, okay? Because basically what we're going to have here is that I want to have 10,000. So I'm going to say 10,000 is equal to 0.95 times some number we don't know. So I'm going to use my algebra and solve for that some number we don't know. It's being times by 0.95. That means I'm going to take the 10,000 and divide it by that 0.9545. And what I'm going to get is 10,476. Nice. So what that means is that this company is going, oh, it went away, but the company is going to have to make that many rods because it knows that some of them are going to be too short or too long and have to be discarded. Okay. All right. So let's come back to this one. It's still the steel rods. This time they're 24, standard deviation 0.06. I think this should be just very similar to what we did. So if you are still getting stuck, let me know, but I hope that works.